this session, we shall look at some special varieties or rather special models from linear equations. They look to be linear, but after certain steps only they can be converted to linear equations. And some of them are specially named as Bernoullis equations. Basically, they belong to the family of linear equations, of course. As we look at them for the first time, they do not look like linear equations, but after some simplification, it can be brought into linear equations. Yes, how can they be in the standard form? Let us observe. Look here, dy by dx plus py is equal to q into y power n. You observe, every part except this looks like a linear equation, and now the changes come into the fray only by the presence of y power n. Actually speaking, in the case of linear equations, this p and q must be functions of x only. Besides q, there is a term containing y power n which abstracts us to say that this is linear in y. Yes, what could be done? What must be done so as to make this linear? We shall look at. You divide throughout the equation by y power n. What happens? 1 by y power n dy by dx plus 1 by y power n minus 1 into p is equal to q. Are we correct? I could have divided throughout the equation by y power n. 1 by y power n dy by dx plus 1 by y power n. What does it mean? 1 by y power n minus 1 p is equal to q. Now, let 1 by y power n minus 1 is equal to t. You suppose, what happens? Y power 1 minus n is equal to t, isn't it? Okay. Therefore, 1 minus n into y power 1 minus n minus 1 into dy by dx is equal to dt by dx, isn't it? Therefore, 1 minus n y power n into dy by dx is equal to dt by dx. Good. Multiply this equation completely with the 1 minus n. What happens? 1 minus n by y power n into dy by dx, nothing but dt by dx. dt by dx plus, what is 1 by y power n minus 1? It is t, and we are multiplying with 1 minus n. Hence it is 1 minus n into t into p is equal to 1 minus n into q. Now you observe, this is surely linear in t. This is linear in t. So, as there is a special heading like Bernoullis equation, only we like to focus our attention on that. Actually speaking, it is a part and parcel of linear equations. You see, we could have divided entirely with y power n. Why should you? Unless or otherwise, this cannot be converted into linear form. On the right hand side, q or function of x must only be present, isn't it? For that purpose only, we could have divided entire equation with y power n. Okay, you have seen how this has been converted into linear form. And actually speaking, such things we generally do while going through the different problems. This is particularly called Bernoullis equation, Bernoullis form, or the form which is convertible to linear form. You can call it as you like, as absolutely in the similar fashion. You can observe some equations which are Bernoulli in X also. We shall now look at them. What will be the general shape of those equations which are Bernoulli's form in X? It's just nothing but dx by dy plus px is equal to q into x power n. That's all. What I mean to say is it is just needless to put a separate heading and separate discussion for that. In a similar fashion, we can be in a position to derive the nature of those equations which look like Bernoulli's form in X. Okay, this is what you say about Bernoulli's equations, and we shall now come across some equations in which this type of procedure is necessary. We need to use this, of course. Of course, without spelling the word Bernoulli, we proceed actually. That is why I like to say this is a part of linear equations only. Yes. As we could just discuss now itself, there are certain equations which look like Bernoulli's equations which are Bernoulli form in X. Let us trace that equation. Dx by dy plus px is equal to q into x power n. That will be the standard form of an equation which is Bernoulli in X. Of course, in the previous model, we could have divided the equation entirely with y power n, and we shall do the same here, of course, by x power n. And 1 by x power n minus 1 is supposed to be some t. Absolutely in the similar fashion, this can be converted to a linear form, of course. Yes. Now, we shall come across such equations in which this type of procedure is needed to solve the equation. Yes. Consider this problem available on the board. Y minus cos x dy by dx is equal to y square into 1 minus sin x into cos x. Isn't it? Okay. Moreover, it has been given y at 0 is 1. Making use of that, we are asked to find the value of y at pi by 3. That is, if x is equal to pi by 3, what happens to the fate of y? That is the main question. Well, look at this question. First of all, let us try to get dy by dx from this. Y minus y square into 1 minus sin x into cos x is equal to cos x into dy by dx. Isn't it? Y minus y square into 1 minus sin x into cos x is equal to cos x into dy by dx. Divide throughout by cos x. What happens? Y secant x minus y square into 1 minus sin x is equal to dy by dx. Okay. Therefore, dy by dx minus y secant x is equal to minus y square into 1 minus sin x. Okay. You look here. Dy by dx plus py is equal to q into y square. This is surely Bernoulli in y. Let us now divide throughout the equation by y square. What happens? Dy by dx by minus 1 by y square, let me divide with minus 1 by minus y square. So this is minus 1 by y square dy by dx plus 1 by y into secant x is equal to 1 minus sin x. You can observe every step is according to the plan of action which has been designed in the case of Bernoullis equation, which we could have just explained for ourselves, isn't it? Okay, what is my plan? I like to take 1 by y as t. 1 by y as t. Put 1 by y is equal to t. Automatically, minus 1 by y square dy by dx is equal to dt by dx. Well, my dear friends, I think you can believe that this can be thrown into the Bernoullis model. Just as there is a special heading, we are speaking of that word Bernoulli. Otherwise, as and when you take 1 by y is equal to t, this is going to be converted into a linear equation, isn't it? Well, so minus 1 by y square dy by dx is just nothing but dt by dx. Therefore, let me call it 1. Therefore, 1 becomes, how does it become? Come on, what is minus 1 by y square into dy by dx? It is just nothing but dt by dx, isn't it? dt by dx plus secant x into t is equal to 1 minus sin x. And surely it is linear in t, isn't it? Is linear in t. Linear in t. Well done. What is the procedure that has been designed to solve a linear equation? In the first step, we may have to find the integrating factor. What is the integrating factor here? This formula is e power integral p dx. This is equal to e power, what is p? Secant x, integral of secant x dx. Let us recall from the knowledge of indefinite integrals, what is the integral of secant x? Log mod secant x plus tan x. This is equal to e power log mod secant x plus tan x. Secant x plus tan x. As it is e power log after the base e, of course, is nothing but secant x plus tan x. This is the IF, isn't it? This is the IF. Okay, so as you look at the given equation, we are not able to say directly it is linear in y because this y square is present. Therefore, we could have got the standard form dy by dx plus py is equal to q into y power something. After dividing it with y square, this has been brought to the linear form, and it is of course an easy matter, very easy procedure we have with our hand, with our discussion and knowledge to solve it. As a part of that, integrating factor is secant x plus tan x. Now we shall design the solution. What is the solution? I like to remove these steps. Please follow this. Come on. Therefore, the solution is, if it is linear in y, we start with y into if is equal to. If it is linear in x, we start with x into if is equal to. But here it is linear in t. Therefore, we have to start the solution with t into if. If means secant x plus tan x is equal to integral of q. What is q? 1 minus sin x into secant x plus tan x. Instead of secant x plus tan x, I like to write 1 by cos x plus sin x by cos x. Sin x by cos x. Any problem? This is q, that is if. Well done. This is equal to integral of 1 minus sin x into 1 plus sin x by cos x dx. Come on friends, you observe the steps. 1 minus sin x into 1 plus sin x. What can it be? It is 1 minus sin square x. What t is 1 minus sin square x? Cos square x. Cos square x by cos x is just nothing but cos x, isn't it? Cos x dx. Actually this is 1 minus sin square x. What is 1 minus sin square x? Cos square x. Cos square x by cos x is cos x. What is integral of cos x? Is just nothing but sin x plus c. Sin x plus c. This is the solution. Let us write the solution clearly. T. What is t? What is t? 1 by y it seems, isn't it? 1 by y we could have assumed to be t. Therefore, secant x plus tan x by y is equal to sin x plus c is the solution. But look at the question, my dear. We are not asked to have the general solution enough. It's not enough. We want to have y at pi by 3. And before that, we are to decide c also by making use of the information y at 0 is 1. Well, after noting down the equation or the heading Bernoullis equation, this is for the first time we are solving this. Actually speaking, in the previous problems also, we could have made use of this style of solution, assuming something is equal to t, of course. So, after noting the heading, this is the very first problem. You see, the observation is very important here. You have to observe that the given equation is in the form Bernoulli. After noting that, some y power n will be there just beside q and divide it with that y power n. In the present problem, it is y square, isn't it? That is y only we could have divided with y square on all the sides, on both the sides of that equation. Okay, this is the solution. 2 more pieces of responsibility laid on our shoulders. What do you want to do? We want to make use of y of 0 is 1 to find c, and secondly, we want to find y at pi by 3. Good. Well, friends, we could have had the solution before us. The solution is secant x plus tan x by y is equal to sin x plus c. Let me make use of y of 0 is 1, but y at 0 is equal to 1. So, secant 0 plus tan 0 by 1 is equal to sin 0 plus c. Secant 0 is 1, tan 0, 0. Y is 1 because y at 0 is 1 he has given, isn't it? Sin 0 is 0 plus c, from which we can directly have c is equal to 1. Well, we are happy. One particular duty is fulfilled, and the other y at pi by 3. What is y at pi by 3? If x is equal to pi by 3, then come on, friend. Secant pi by 3, what is it? Secant 60, what is it? 2, because cos 60 is half, secant 60 is 2. 2 plus tan pi by 3, tan 60, what is that? Root 3. 2 plus root 3 by y is equal to, what is sin x? Sin 60, sin pi by 3 is root 3 by 2 plus c. What is c? We could have calculated it to be 1, isn't it? Okay, this is equal to 2 plus root 3 by y is equal to root 3 plus 2 by 2. You can cancel 2 plus root 3, which lies in numerator on both the sides, so that y is equal to 2, isn't it? Therefore, y at pi by 3 is equal to 2 is the right answer, is the right answer. This is the beautiful example of a Bernoullis equation. The next question, which has a shade of Bernoullis form. We can observe the same style of solving in this equation also. So, to make the idea very firm in our mind, I would like to tackle with one more such problem in which Bernoullis form might be seen. Yes, look at this. X square y cube plus xy into dy by dx is equal to 1, and y at 1 is 0. Then he is asking in a different way. y becomes root 2 when x is equal to how much? So we are supposed to have the value of x for which y is equal to root 2. Okay, let us try. Well, my dear, if you have dy by dx is equal to 1 by x square y cube plus xy, isn't it? From which we cannot get any help. It cannot be thrown into any type of standard model, isn't it? It's useless. If you have dy by dx directly, it is 1 by x square y cube plus xy. So no use. So I like to find dx by dy. From this, what is dx by dy? You just send this to this side so that it is x square y cube plus xy. X square y cube plus xy. Well, dx by dy minus xy is equal to x square y cube. Come on, dear. This is Bernoulli in x because we could have started with the dx by dy. Come on, recollect the standard form of that equation which is Bernoulli in x. Please recollect the standard form of that differential equation which is Bernoulli form in x. What is that? Dx by dy plus px, what is p here? Minus y is equal to q into x power n. In the place of q, what do you have? Y cube we have. In the place of x power n, what do you have? X square we have. Well done. So you might have understood already what is going to be done. We could have learned in the style of solving a Bernoullis equation. This is Bernoulli in x. So with what quantity should you divide? X power n. That is, what is it here? It is x square. Okay, let me divide with the minus x square. It is a matter of calculation purposes, that's all. Minus x square I am dividing. Come on. Minus 1 by x square into dx by dy plus 1 by x into y is equal to minus y cube. Am I correct? I could have divided with minus x square. Minus 1 by x square into dx by dy plus minus x by minus x square is nothing but plus 1 by x into y is equal to minus y cube. Come on, here I would like to take 1 by x is equal to t. Differentiate this with respect to y. What happens? What is the derivative of 1 by x? Minus 1 by x square into dx by dy is then dt by dy. Am I correct? dt by dy. So this part becomes dt by dy. Let me call this 1. So 1 becomes what is minus 1 by x square into dx by dy? It's just nothing but dt by dy. dt by dy. 1 by x is t. ty is equal to minus y cube. Minus y cube is surely linear in y or t? T, because we have started with dt by dy in t. Well done. We continue to use the procedure that has been designed for linear equations. In that action, that plan of action, what is the first step? IF, that is the integrating factor, is equal to e power integral p dx or p dy. P dy. What is p here? Y. Y dy. What is the integral of y? E power y square by 2. E power y square by 2. That's all. This is IF. What is integral of y? It is y square by 2. Well done, well done, well done. Therefore, the solution is, come on, How to start with the solution? T into IF, that is T into e power y square by 2 is equal to integral of Q. What is Q? Minus y cube. Minus y cube into e power y square by 2 dy. Isn't it? Okay. This is equal to, I like to make very simple adjustments here. You look here. Integral of, what is this? Minus y cube. Y square by 2 into e power y square by 2 into y dy minus of, no, minus 2 into, let minus preserved, 2 into 2 cancelled, y square into y cube. Any problem? Why is it necessary to do all these things? If you take y square by 2 is equal to some u e power u du. You take y square by 2 is equal to some u. If you differentiate it with respect to y on both the sides, y dy is equal to du, isn't it? So this is equal to minus 2 into u e power u du, where u is equal to y square by 2. Y square by 2. Good. What is the solution? Ultimate solution. Therefore, the solution is t into, what is t actually? What is t? 1 by x into e power y square by 2 is equal to minus 2 into, from the knowledge of indefinite integrals, especially from the knowledge of integration by parts, you can recollect that the answer of integral of u into e power u is e power u into e minus 1, isn't it? E power u into u minus 1 plus c, that is equal to minus 2 into, what is u? Y square by 2. Y square by 2 into y square by 2 minus 1 plus c. Plus c. Okay. This is the solution. Well, there are still 2 steps remain. What are those steps? Y at 1 is 0. But y at 1 is 0. That is, what does it mean? If you substitute x is equal to 1, y must be 0. That is, 1 by 1 into e power 0 is equal to minus 2 into e power 0 into 0 by 2 minus 1 plus c. What is e power 0? 1. By 1 is 1. This is minus 1. E power 0 is 1. Minus 2 into minus 1 is plus 2. Therefore, c is equal to 1 minus 2 is equal to minus 1. Am I right? What is c? Y at 1 is 0. If you take x equal to 1, then y is 0. Substitute here. 1, 0, the point 1, 0. You substitute here in this curve. 1 by 1 into e power 0 is equal to minus 2 into e power 0 into 0 by 2 minus 1 plus c. Minus 1 into minus 2 is 2. c plus 2 is 1. So c is 1 minus 2. That is minus 1. c is equal to minus 1. We are happy. We are able to get c. And still there is one more thing. What is the value of x when y is root 2? What is the value of x when y is root 2? We are supposed to calculate it, estimate it. Now, if y is equal to root 2, then, come on, substitute root 2 in the place of y. 1 by x into e power. Root 2 whole square is 2. 2 by 2 is 1. Is equal to minus 2 into e power. Y is root 2. Root 2 whole square is 2. 2 by 2 is 1. Into y is root 2. Root 2 whole square is 2. 2 by 2 is 1. 1 minus 1 plus c. But c is minus 1. We could have already got it. We could have already obtained it. Okay, 1 minus 1 is 0, 0 into anything is 0, therefore e by x is equal to minus 1. E by x is equal to minus 1. Therefore, x is equal to how much? Minus e. X is equal to minus e. That is, y at minus e is root 2. What is the value required? The value of x which makes y root 2. In order to have y is equal to root 2, you may have to substitute x in the place of x minus you may have to substitute. Yes, that is the answer. It's also a beautiful question. It is Bernoulli in x. Well, my dear, after taking the heading Bernoullis equation, we could have taken one problem Bernoulli in y and this problem Bernoulli in x. Actually speaking, they are to be converted to the linear form. That particular part of dividing throughout with either with y power n or x power n, that is the only additional part, and the remaining part is entirely that of linear model. That of linear model. Well, we shall go through one more such problem. Another problem. The next problem is ready for us on the board. Let us observe this. X plus 2y cube into dy by dx is equal to y. You may get it out. You may suspect it. It might be in Bernoullis form. Let us see. Everything will be made clear if you try to get it into the standard form. Okay, friend. If you get dy by dx is equal to, what happens? Dy by dx is equal to y by. Nothing is useful for us. It cannot be brought into the standard form. Therefore, dy by dx creates less utility. So let us try to get dx by dy. That is, send this here, bring this here. What happens? Dx by dy is equal to x plus 2y cube by y. That is equal to x by y plus 2y cube by y is nothing but 2y square. Therefore, dx by dy minus 1 by y into x is equal to 2y square. Come on, friends, is it linear or Bernoulli? It is directly linear in x but not y. You can easily observe it is dx by dy minus px is equal to q. Both p and q are functions of y. Well said. This is therefore linear in x. Is linear in x. Therefore, if is equal to e power integral p dy. What is integral of minus 1 by y? Minus log y is equal to e power minus log y. Or you can write minus log y as log 1 by y. Log 1 by y is just nothing but 1 by y. Therefore, e power log 1 by y is nothing but 1 by y. Hence, integrating factor is 1 by y. Well, what about the solution? Therefore, the solution is x into integrating factor is equal to q into, what is q there? It is 2y square. 2y square into 1 by y dy. It is nothing but 2y dy is y square plus c, x by y is equal to. Therefore, x is equal to y cube plus cy is the general solution. By the by, what is the question actually? He has asked us just to have the general solution itself. Therefore, the general solution is x plus y, x is equal to y cube plus cy is the general solution. A beautiful problem. The next question is before us. Root x square plus 1 into dy by dx plus y is equal to root of x square plus 1 minus x. Then, what is root 2 plus 1 into y at 1 minus y at 0? Well, my dear, the problem is so simple. solution will also be simple. But you see, the question that we require is root 2 plus 1 into y of y at 1 minus y at 0. Some calculation is needed, that's all. So the time will be must be allotted to find it. And solving this is very simple. Why? Because you divide entire equation with root x square plus 1. What happens? Dy by dx plus 1 by root x square plus 1 into y is equal to root of x square plus 1 minus x by root of x square plus 1. You can easily say that this is surely linear in y. Beautiful. That has been brought into the standard form directly. Dy by dx plus py is equal to q. Okay, of course, this may look bulkier, but the answer, the solution is very simple. You can enjoy it like anything. Look here. Therefore, it is, what is the integrating factor? E power integral 1 by root of x square plus 1 dx. Come on friends, what is the integral of 1 by root x square plus 1? There are two types of answers. One is sin h inverse x and another is log mod x plus root of x square plus 1. Which is beneficial for us? Which saves time for us? Log mod x plus root of x square plus 1 is beneficial here. Why? Because log mod x plus root of x square plus 1 is this integral. Hence it is x plus root of x square plus 1. Because this base is also if is obtained, therefore solution is y into if is equal to integral of, come on, q into if. What is q? Root of x square plus 1 minus x into if. What is if? I would like to write this if as root x square plus 1 plus x. Observe it very carefully. A minus b into a plus b. A square minus b square. X square plus 1 minus x square. What happens? 1 will remain there. Hence it is integral of 1 by root of x square plus 1 dx. And again this is log mod x plus root of x square plus 1 plus c. Therefore, y into x plus root of x square plus 1 is equal to log of x plus root of x square plus 1 plus c is the solution. Well, my dear friends, you please observe the style of getting this solution. How easier it is. How easier it is, the process of getting the solution. Well, just to have the general solution is not enough for us. We are to find root 2 plus 1 into y at 1 minus y at 0. That is the actual risk. That is the actual needful item which we are now going to do. The solution is before us. We have to find root 2 plus 1 into y at 1 minus y at 0. First of all, what is y at 1? You find it. If x is equal to 1, then, come on, substitute 1 in the place of x. What happens? Y into 1 plus 1 square plus 1 is root 2 is equal to log of 1 plus root 2 plus c. This is y into 1 plus root 2. Y into 1 plus root 2 is equal to log of 1 plus root 2 plus c. What is y? What is the value of y here from this equation? Is nothing but the value of y which has been obtained by taking x is equal to 1, isn't it? So from this we can have y at 1 into root 2 plus 1 is equal to log of 1 plus root 2 or root 2 plus 1 plus c. Okay. We call this equation 1. Next, y at 0. What is y at 0? If x is equal to 0, then, come on, y into 0 plus 0 square plus 1 is 1 is equal to 0. 0 plus 1 is 1. 1 plus 0 is 1. Log 1 is 0. 0 plus c is c. Is c. Now, so y into 0 plus 1 is nothing but y. Therefore, y at 0 is equal to c. Y at 0 is c. Now, subtract this from this. This minus this is c and c will be cancelled, leaving you log of root 2 plus 1, that's all. Therefore, 1 minus 2 implies, first equation minus second equation implies y at 1 into root 2 plus 1 minus y at 0 is equal to, you just subtract c. What is going to happen? Log of root 2 plus 1 is the right answer. In the beginning, we may get confused, or we may feel boresome. Oh, well, and their expression is asked here. We may have to calculate all those things, etc. You see, we could have got root 2 plus 1 into y of 1 directly, isn't it? And y at 0 is a simple item. You are just supposed to subtract this from this. So that we have y into root 2 plus 1 minus y at 0 is a log of root 2 plus 1. Beautiful. It's a nice question. The next question is before us. X square into x square minus 1 dy by dx plus x into x square plus 1 into y is equal to x square minus 1. To solve this equation, of course, is of no pain and strain. It's very simple. If you can divide this entire equation with x square into x square minus 1, that can be directly brought into a linear form. You see, here also, just like in the previous case, here also the question is y into x minus 1 by x minus ln x is equal to how much? You may have to find y, and you have to obtain y into x minus 1 by x minus ln x, that is log x to the base g. That is the actual requirement here. And as a matter of that, let us first find the solution of the equation. Divide entirely with x square into x square minus 1. What is going to happen? Dy by dx plus x into x square plus 1 by x square into x square minus 1 into y is equal to 1 by x square. Is it right? Of course. Is linear in y? Surely linear in y. Dy by dx plus py is equal to q. Come on friend, what is if? E power integral. This by this means 1x will be cancelled. So that what happens? X square plus 1 by x into x plus 1 into x minus 1 dx. Okay. And everybody knows the style of integrating this. Yes, of course. We are supposed to make use of partial fractions here, and even that is not difficult. By x plus 1 by x minus 1. What is going to be obtained here? You put x equal to 0, 1 by 1 minus 1, 1 into minus 1, this is minus 1. Next, for this, put x equal to minus 1, minus 1 whole square is 1, 1 plus 1 is 2. This is minus 1, minus 1 minus 1 is minus 2, minus 2 into minus 1 is 2, this is 2, 2 by 2 is 1. And for this, you just take x equal to 1, you close this, 1 plus 1 is 2, 1 plus 1 is 2, 2 by 2 is 1, so it is 1 dx. Well, therefore this is e power, for this is log mod x plus 1, for this is log mod x minus 1, for this is minus log mod x. So it is log x plus 1 plus log x minus 1 minus log x. Log m plus log n, log mn, that is log x square minus 1, and that is minus log x. All together this is e power log x square minus 1 by x, and at last you will be having x square minus 1 by x as the integrating factor, isn't it? So it is log x plus 1, log x minus 1, minus log x, and the sum of these two, log m plus log n, is log x square minus 1. Log x square minus 1 minus log x, log of x square minus 1 by x, and that becomes the actual IF. Well done. Solution is y into IF is x square minus 1 by x is equal to integral of q. What is q? 1 by x square, isn't it? 1 by x square into x square minus 1 by x dx. Good. Y into x square by x is x minus 1 by x. We should feel happy. We should feel happy because in the question directly y into x minus 1 by x is asked, isn't it? We are going to have without pain and strain, of course, is equal to x square into x, x cube. X square by x cube is 1 by x minus 1 by x cube minus 1 by x cube dx. Well done. What is the integral of 1 by x? It is log mod x or log x to the base c minus 1 by x cube. What is the integral of 1 by x cube? Minus 1 by 2x square plus c. And you just bring that log x this side. Y into x minus 1 by x minus log x to the base c is nothing but ln x is equal to 1 by 2x square plus c. That's all. There ends the matter. Why? Because the actual question asked us is nothing but this. Y into x minus 1 by x minus ln x. That's all. In the beginning, we suspected it. Oh, there is a lengthier question. We may have to approach it and calculate it by sparing some time. Nothing is needed there. Therefore, the solution is, this is the general solution and the requirement also. So what is y into x minus 1 by x minus ln x? Is just nothing but 1 by 2x square plus c is the right answer. A beautiful question. The question looks bulkier, but solution is so simple and slim, isn't it? The next question is before us. No doubt some speciality is there in this question. First of all, you may suspect in what chapter, to what chapter does it belong? Derivability or limits or integration, differential equations. Such doubts may occur. Look here. What is f? Is differentiable on the positive region, set of positive real numbers, that is open interval 0 to infinity. And f of 1 is 1, he has asked. The additional information is this. Then f of x is equal to. Let us try. Now, let me use the L'Hospital's rule for this limit. What happens? Limit as t tends to x, derivative of 2 square is 2t into f of x minus x square into f dashed t by 1 is equal to 1. Isn't it? I could have found the derivative with respect to t because I am supposing t as the main variable here. Okay, right. As t tends to x, this is nothing but 2x into f of x minus x square into f dashed x is equal to 1. Is equal to 1. Right. Now, let me take y is equal to f of x, automatically f dash x will be dy by dx. Let y is equal to f of x. Then dy by dx is equal to f dash x. Call this equation 1. Therefore, 1 becomes 2x into y minus x square into dy by dx is equal to 1. Or x square into dy by dx is therefore equal to 2xy minus 1. 2xy minus 1 divided with x square. What happens? Dy by dx is equal to 2x by x square is 2y by x minus 1 by x square. Bring that 2y by x this side. What is going to happen? Dy by dx minus 2 by x into y is equal to minus 1 by x square. You look at the problem. Where did we start? Using LH rule. Where we could arrive at a linear equation. In the beginning of the problem, we cannot expect that this is a problem in linear equations. This is linear in y, one of the most standard forms. Dy by dx plus py is equal to q, isn't it? In the place of p, what do you have? Minus 2 by x. And in the place of q, what do we have? Minus 1 by x square. Well, let us not waste time. That is the first step to be implemented. IF. What is IF? IF, that is integrating factor, is equal to e power integral minus 2 by x dx. Okay, this is equal to e power minus 2 log x. Minus 2 log x, of course, can be written as log x power minus 2. E power log. Therefore, IF is x power minus 2 or simply 1 by x square. 1 by x square, isn't it? Okay, we have almost reached the position of climax. We are just to have the solution. IF has been obtained. We want to have the solution, that's all. Let us now make use of the formalities of linear equations to write the solution. Well, therefore the solution is y into integrating factor is equal to integral of q. What is q? Minus 1 by x square into 1 by x square dx. This is 1 by x power 4, of course, isn't it? What is the integral of 1 by x power 4? Minus 1 by 3x cube. Minus 1 by 3x cube plus c. So, y by x square is equal to 1 by 3x cube plus c. Well, is it over or is there anything remained? My dear friend, you please notice that one more piece of information is there which is not yet used. What is that? F of 1 is 1. What is f of 1? Y at 1, isn't it? But f of 1 is 1. What do you mean by f of 1? Y at 1 is 1. That is 1 by 1 square is equal to 1 by 3 plus c. What is c? 1 minus 1 by 3. 2 by 3. 2 by 3. Therefore, the solution is y by x square is equal to 1 by 3x cube plus 2 by 3. Let me multiply with 3x cube on both sides, so that we have 3xy is equal to 1 plus 2x cube is the right answer. That is the solution. Observe the problem carefully, how particular it is, how special it is, how beautiful it is. This is the speciality of this problem.